Alright, so we are going to now learn the shortcut for derivatives. So that's nice. We get away from the hard stuff. So there's some rules, and I suggest you memorize these rules because it makes things easier. So the first rule is that the derivative of a constant is a constant. So if we look here, find the derivative of each function, we call that f prime of x. So here, y equals 7, the derivative of that is just 0. So you can say f prime of x equals 0. Here, derivative of 0, 0. Derivative of negative 3, 0. Now the next one, if k is a constant, pi we know is a constant, remember that. Pi is a constant. And in calculus, anything that's not x is usually constant. So here, f prime of x is equals 0. Okay, now to just take the derivative of a rational number, okay, and if n is a rational number, okay, the function x to the n is differentiable. Okay, so it's just a power rule. Okay, so what we do to take the derivative of any x to a power is we multiply the power to the front and then subtract the exponent. So for this first one, f prime of x equals, we take the power and move it to the front, and then we subtract our exponent, so our answer is 3x squared. Okay, b is a little different because we need to change it first. Change it to x to the 1/3. So then to find the derivative, 1/3 x to the 1/3 minus 1, which gives me 1/3 x to the negative 2/3. You can keep it like that, or you can change it to 1/3 times x, the cube root of x squared. So how I know that is the power is in the sky, the root is in the ground. Alright, c. Before we can take the derivative of c, we also need to change it to x to the negative 2. So then to take the derivative, we multiply the power to the front, then subtract. So we get negative 2x to the negative 3. So that's negative 2 over x cubed. Alright, d, we don't have to do anything to it. F prime of x is just going to equal 5x to the 5 minus 1, which gives me 5x to the 4th. E, we need to change it. So we're going to change f of x to the 3 over 4. We multiply the power to the front, and then we subtract 1. Sorry, I'm going to show that I'm actually subtracting 1. 3/4 minus 1 gives me 3/4 x to the negative 1/4. And simplify 3 over 4 4th root of x. Okay, this next one again, because it's at the bottom, we need to change our function to x to the negative 3. So then our derivative is going to be negative 3 x to the negative 3 minus 1, which is negative 3x to the negative 4. Okay, so now we're going to find, the instructions did the derivative, but at a point. A little funky thing here. So it says find the slope of the graph of x to the 4th at each of the given points. So the first thing we need to find is find the derivative of the function, because remember what it's asking us is, here's the graph, and remember that graph looks like this, right? So they want us to find the derivative, and then we're going to figure out the derivative at every specific point of that graph. So the derivative here is 4x cubed, okay? And the derivative graphically, that's a cubic function, right? So it looks like that, right? And so then we're plugging in x equals negative 1. So 4 times negative 1 cubed is 4 times negative 1, so it gives me negative 4. So what that's saying is the slope of that graph at x equals negative 1 is negative 4. Okay? So same thing here. It wants the slope at 0. Well, that's just going to be 0. Okay? And then they want the slope at 1. And that's just going to be 4. Okay? Now you can see that if you drew the graph of this function and you look at that point, that's what the slope is going to be at that point. Okay? Alright, this one is an important one. This one comes up on a test all the time. I've seen it so many times. Find the equation of a tangent line to a graph at f of x equals x squared when x is negative 2. So, first of all, they want an equation of a line. Okay, so if we think about an equation of a line, y equals mx plus b, we need an m and we need a b. Well, first we got to find our slope. Well, to find the slope of this, slope is the derivative. So the derivative of that is 2x. Okay, but it's at the point x equals negative 2, right? Because I need an actual number for m. Okay, so I'm going to do 2 times negative 2, and that gives me negative 4. So my slope at that point is negative 4. Now, to find b, I would need an actual point, right? Well, they told me x is negative 2, but I need a y value. So if we go back to our original equation and we plug in negative 2, my y value for the original function at negative 2 is 4. Okay? So this is the point I'm going to use to find the equation of the line. So we know we can plug this into y equals mx plus b. So I get 4 equals 8 plus b equals negative 4. So my equation of a line would be y equals my slope, x minus 4. Okay? Alright, another rule about derivatives is the constant multiple rule. So the constant multiple rule says that if there's a constant times a differentiable function, you can just take the constant out and then differentiate the function. Okay, so if we look at a, I'll zoom in here, our constant here is 5. So what it's saying is I can take 5 out and then just take the derivative. D dx stands for the derivative. That's important to know. X cubed. And this is one of the times where I start using that. So that means it's 5 times the derivative of x to the third, and that derivative is 3x squared, which gives me 15x squared. So b, because it's a fraction, I need to rewrite it, so it's 2x to the negative 1, okay, which means I'm going to take out the 2 and then take the derivative of x to the negative 1. So that gives me 2 times negative 1x to the negative 2, and if I simplify that, I get negative 2x to the negative 2, which gives me negative 2 over x squared. Okay. Next one. So my constant here is 4/5 times the derivative of t squared. So that gives me 4/5 times 2t, which gives me 8/5 t as my derivative. Alright, d, my constant is 2, and I'm taking the derivative of the square root of x. I can rewrite the square root of x as x to the 1/2. So that's 2 times 1/2 x to the negative 1/2, which gives me x to the negative 1/2. So that's 1 over radical x. Alright, e, 1/2 is my constant. And this one's really fun. We're going to take the derivative of x to the negative 2/3. So that's 1/2 times negative 2/3 x minus 5/3, because we subtracted 1. And that equals negative 1/3 x to the negative 5/3. So final answer is negative 1 over 3 cubed root of x to the 5th. Okay. Next one, our constant is negative 3/2. X is our function. The derivative of x is just 1. Here's the reason. Ignore that, that's on the next page. So derivative of x to the first, right? It's going to be 1x to the 1 minus 1, which gives me 1 x is 0, which is just 1. So the derivative of x is just 1. So I get negative 3 halves times 1, which gives me negative 3 halves. Okay? Alright, last thing. Sum or difference. The derivative of the sum is the sum of the derivative of the differences. Derivative of the difference. I don't think those are plus. So the derivative of the sum is the sum of the derivatives. Derivative of the difference is the sum of the derivatives of the difference. So all this is saying is I can take the derivatives individually. Okay, derivative of x cubed is 3x squared minus 4 times the derivative of x, which is 1, plus derivative of that is 0. So my answer is 3x squared minus 4. Okay, so b x negative x to the fourth over 2 plus 3x cubed minus 2x. So if you notice when I write this, I go ahead and take my constants out. Okay, so I got negative 1/2 times the derivative plus 3 times the derivative minus 2 times the derivative. Then I simplify. Negative 2x cubed plus 9x squared minus 2. And that's the answer. Alright, that's it for today.